I'm going to be talking today about a useful tool that exists in a lot of programming languages called object-oriented programming. Let me go ahead and actually, I'm just trying to figure out the best layout here. I got myself a new monitor, so just trying to figure out, let's see. There we go. Don't need anything with that. There we go. So, so I'm recording, and now let's go ahead and share screen. We're gonna share this chat. There we go. Yes, I know participants can now see my screen. That's why I hit share screen. All right. So one of the most useful tools in programming is a concept called object-oriented programming. So I'm just going to call this all about objects.py. All right. So, and I alluded to this at the end of the last lecture.
I have a question.
Yes.
Will we need to know this for the exam?
No, but it can help, and it might help you with your final project, depending on how you want to organize stuff, right? You don't have to follow along in idle. You can follow along on my computer. I'm going to be introducing a concept here, and I'll be talking about it, and then we might look at applying it here. So the idea here is that now that we're dealing with large projects, it's all about what is the best way to organize our code. And part of what we've been learning is that since a lot of times what we're going to be doing is we're going to be running a program and having it do something, right? I should be able, yeah, I can demo. I can take demos after class. And this might be a shorter class since I'm trying to just get this concept to you guys. Since we're doing things, we often need to organize the, we found one structure of organization, which is functions, because they do stuff. As I've compared it to function, when we write a function, we are essentially we are essentially creating a verb. We are creating a verb that is added to the Python programming language for the duration of, let's say, our conversation running. In other words, it exists for as long as we run the program. And that's fine because, things need to happen in any story, in any kind of event. So you could argue that verbs are possibly the most important thing because, without it, nothing happens. But you need nouns as well, which are, without nouns, nothing in a story would, happen to anyone because there would be no one doing the actions. So we've been dealing with the built-in nouns in Python for a while. And these nouns are called objects. Well, more specifically, nouns are classes, and an individual noun is an object. So we've been dealing with these all the time. For instance, X is an object over here. X dot, and because as soon as I hit dot, it gives me a whole bunch of things, including all these weird underscore things. Okay, let's go ahead and say X dot bit length. Run it, and it tells me it's a built-in method, so I should call it. And it tells me that it's 3, and I guess that makes sense because in binary, a 5 is 101, right? Which is 4 plus 1, right? So in binary, again, the way it's done is that basically this is the 1's place, this is the 2's place, and this is the 4's place. And then the next place would be the 8's place. And then, so basically we would add 0 8's, 1 4, 0 2's, and 1 1. Integers are basically stored like that in computer, and that's how they're stored in binary. Working with these things are tedious, That's off. So oftentimes we'll just simply compress them into hexadecimal, but that's not necessarily important for today's discussion. Similarly, we've been working with another type of object this entire time, the string, right? S dot, and we've got all these things, and it's and Microsoft is trying to tell me, hey, these things happen a lot, and it's helpfully telling me also what these things do. So, but we can see capitalize, right? And what this does is that it tells the word, hey, give me a new word, right? Because we can't change strings, they're immutable. A lot of objects are, most objects we deal with in Python that are built into Python are immutable, meaning you can't change them. You can't change strings, you can't change integers, you can't change doubles, right? Anytime you do change it, instead what you're doing is replacing it, right? So, so we've been dealing with objects all the time. The more complicated objects we've been dealing with, the most complicated object I think we've been dealing with so far is been the turtle object, right? Which what we do is that basically we would say something like we'd import turtle, and then we'd do this weird thing where we'd say Bob is equal to turtle.turtle, and we were like, why in the world are we doing this turtle thing? Do we just, is this just, are you just trolling us, kind of deal? And then we would say, but that would give us a turtle, and now we could give it commands like, please move forward 100 spaces. And you won't be able to see that because, I'm only sharing this screen. That doesn't really matter for the purposes, but we had this and we were like, why in the world are we doing this? But eventually you just like, whatever, turtle.turtle, that's how you make a turtle. It's the magic word. Well, it's not going to be magic anymore. So, so built into Python are basic programming concepts, but what we need also is the ability to, we can't predict like, hey, is there going to be a new magical type that we need later on? So we want to make the programming language itself to be extensible. We want to be able to add on to it. And so if we want to create new types, new nouns for a programming language, we need to be able to do so. So I'm going to create basically a very basic kind of, idea. So the entire point of a programming of classes and objects is that we're basically trying to represent a new type. We're creating a blueprint for building them. So I'm going to go ahead and basically, I'm going to create a new class called, well, let's go with shape. Shapes are easy. Class triangle. Okay, so that's what I did. I just simply said class triangle. Boom. That's how I define a new type. And is that enough for me to do it? I wonder. Because I've worked most of this in, do most of my object-oriented programming in Java, right? And so I'm just going to experiment a bit because, again, object-oriented programming, Java was kind of made as an object-oriented programming language, and you were intended to do everything in an object-oriented format. So that's where I'm coming from. But can I do t is equal to new, not new, t is equal class triangle. Let's see if that works. I doubt it, but let's see. Or does it give me an error? No, it does not. Print t. So I've just went ahead and I've run this, and so the perks of Java is that Java is a compile once, run anywhere language. That is basically the big thing. What makes Java a unique programming language is the Java virtual machine, which is basically a very efficient virtualized computer that runs on the computer hardware. Most programming languages fall into one or two categories. They're compiled, like C++ or C is. Compiling a program makes it very fast. It's basically if you take a program, you take the program and you translate it into a different language. More specifically, you're translating it into the machine's assembly language. Okay. And the compilers are very good at optimizing the code for this. And then that's what gives you executables that you can run. Python is an interpreted language, which rather than taking the entire language and trying to translate it, it translates it line by line, much like an interpreter at the UN might be doing as he's listening in and translating. Java kind of blurs the line between the two, where it's compiled for a virtual computer, and that virtual computer has these super efficient commands that get translated to the computer. It's a very blurry thing. But the effect of this is that the Java virtual machine, this virtual computer is very lightweight for pretty much every platform these days. So if you write Java code, you can run it pretty much on anything, and you don't have to compile it. You don't have to compile it multiple times, or once for each machine. So that's kind of the advantage there. But again, it really comes down to personal preference a lot of these days. Also, Java has some very strict rules about public-private ownership, and it kind of makes the specifically when it comes to like accessibility in a programming language. And we're not talking like accessibility is making it accessible to people, but like making variables accessible to other variables. The other thing about Java is that it is much more, it's not as concise as Python is able to be, but it is very concise when you compare it to C or C++. Java and C# are pretty much, you'll see that they're very similar. So anyway, so what did I do here? I printed out this program, class triangle pass, which if you remember means just that all I do is that says there's something supposed to be indented here. Forget about it. Okay. And then then what we do over here is that we create an object using constructor, and then we printed it out and it says main triangle object. So it says __ main dot triangle object at memory location. So we recognize that we've got these memory locations. What in the world is __ main? Well, it's the name of the program we're currently running. And so it's saying the triangle object inside the program we're currently running. So let's go ahead and define some variables. So we're going to look at what a triangle has. Okay. So just trying to make sure I get this right, because the notation is slightly different between one language and another language. So okay. So the first thing we're going to do is we are going to create a constructor. So we have to ask ourselves, what defines a triangle, right? What attributes define a triangle? Well, so okay, let me go ahead and because I've asked something a bit ambiguous. Yeah, so we have 3 sides. That's right. So a triangle is a 3-sided shape. And what differentiates each triangle from any one triangle from any other triangle is the size of those sides. The angles aren't actually as important because, the angles total 180 degrees. But for differentiating one triangle to another, the sides are more important, because you can have, we can have a triangle that's equilateral, right? 5, 5, and 5. And then we can bump it up to a 6, 6, 6, and then to a 7, 7, 7, and 8, 8, 8. It's not really going to change the angles. So the sides differentiate one triangle from another. But yeah. So what we're going to do is that we are going to write what's called a constructor. Now in Java, the constructor basically looks like this. Sorry, in Python, the constructor looks weird, but I'll walk you through it. Now, what is a constructor? It's the instructions over here. Constructor is the instructions that Python knows how to build an object. So over here, I have the t is equal to triangle, and this calls the constructor. Currently, it's empty, so it just basically says we have a random object here. There's nothing going on here. a random object that doesn't have any information in it. Well, with the constructor, we're going to specify, hey, we need the triangle to have 3 sides. So the syntax is going to look weird here, but I'll walk you through it. Def __ init. So that is understood by Python to be the what we're going to be using to call constructor. Self. So this is all going to be black magic for about 10 minutes. So just let the confusion wash over you. Let's go ahead and call them ABC as our sides. No, side 1, side 2, side 3. Okay. And then I'm going to say, so we have self, and then let's go ahead, self dot, let's see, what should I call it? Should it be do you want ABC or side 1, side 2, or side 3? Doesn't matter, just which would you prefer to see?
Side 1, 2, and 3 probably make more sense.
Okay, let's do side 1. And all we have to do now is do this. And now def. And now I'm going to write another function. So yes, again, what I'm doing is should not make any sense to you if this is the first time you're seeing it. It should make somewhat sense because you see, you've got variables and stuff, but then I've got this self dot side, and with self, what the heck is self? Is that me? No. Chill. So self dot side 1. Oh, notice that it recognized that side 1. Self dot side. Oh, right. I have to fix this. And now it should recognize side 2 as a variable. And plus self dot side 3 recognizes that as a variable. And it's telling me, hey, you know, you're supposed to do, you're in Python, so you need to do it like this. Okay, fine. I'll do it like that. Magic. All right. So now if I try to run this, the program should crash, and it says, okay, now it's telling me T triangle, you crash in here. It says init is missing 3 required positional arguments. Okay, first off, I never called init. So why is it crashing on trying to call init? Second off, it's missing 3 required arguments. It says side 1, side 2, and side 3. But what the heck? It takes in 4 arguments, right? So first off, we can do something. I mentioned that this is calling the constructor. And then I said, this is the constructor. Okay. So we can kind of basically say, kind of intuit that basically that I've got a class that I'm calling this, and this is going to be making the triangle. Now it says init needs 3 arguments, but I'm taking in 4 here. So init is, so let's go ahead and explain a bit. First off, anything with underscores inside of a class is private, meaning that that once it's made, I can't access it, or rather, basically it's accessible only by the class. It's internal to the class. Don't touch it. These are basically the insides of the class. And if you go around mucking around the insides without knowing what you're doing, you could break my class, and that would be bad. So don't do that. That's what the underscores do. They kind of tell Python to hide it from any other programmer. So triangle, what we're doing there is basically, so init is one of those special classes called constructor. And what it does is that it gives instructions on how to build it. Self is what we're building. That's going to be passed in automatically. We can call it self, or we could call it me, or whatever, but self is generally the way that Python refers it to. Self is always a function inside of a class in Python. It's a weird peculiarity of Python, but basically it's saying, hey, this is the object we're currently working with. This is the current triangle that we're currently working with, okay? And then we take into 3 sides. because we want to define what those 3 sides are. And basically, we're saying in this one, the triangle's side 1, it's going to be equal to this. The triangle side 2 is going to be equal to this value, and side 3 is going to be equal to this value. So I can create a 3, 4, 5 triangle, right? And okay, and then I can run it. It's not going to crash anymore. But here's the cool part: t dot get perimeter. So I'm going to call this, instead of t, I'm going to call it my triangle, because it is my triangle. Okay. Is self a module of init, or we just create that variable? Self is part of the class. It is basically referring to the triangle that we currently are working on. The triangle we are currently making. So here, 3, 4, 5, we're calling get perimeter on it, and it returns 3 plus 4 plus 5, which is the perimeter of this. So that is 12. So we've created a triangle class, which is pretty cool. Okay. Now, again, so we have this init over here. So let's go ahead. Is this similar to is it similar to this in C Sharp? Yes, it is exactly the same as this in Java or in C Sharp. That's exactly what self is. The difference between this, the keyword this in Java or C Sharp, and self in Python is that you have to tell me what is that. Python wants to know what we're going to be calling it. So you could call it this. You could call it self, which is one of my professors, he'd like to call it me, because it was referring to, it was shorter than writing self. And then you always have to provide it as a parameter. So when we call get parameter, we're saying we're running this on a triangle that we've created. Okay, makes sense, right? You can't call get perimeter. What? You can't call get perimeter? No, you can't call get perimeter without it being inside of a, right? It's inside. Whoops. Let's see. It's inside of this class. So you're not going to be able to call it. It's inside of this object. So what is the difference between a class and an object? Let's first kind of figure out that thing, that kind of category. So, right, there's this kind of Euclidean ideal of a triangle that exists, right? Let's see if I can figure that out. So I'm going to dump some philosophy on you because I'm sorry, but I'm not really sorry because the idea is kind of fascinating. So the idea here is that that there's some kind of ideal domain of ideas was one of the idea the ancient Greeks had, which was that basically that for everything that exists in the world, it was but a pale reflection of basically some ideal. Take a triangle, for instance. The abstract ideal of a triangle could be any triangle, but once we kind of drew one, that would basically we'd be hammering it into existence, and it wasn't abstract anymore, and it was kind of lesser because it had specific side lengths and specific angles. And that's kind of what's going on the relationship between classes and objects. A class is basically a type of something, a type of triangle. So here we're defining the class triangle, and we're basically saying there's a thing that exists called a triangle. You create it by defining 3 sides and assigning those to the object. Okay. And we also created a function called get perimeter that tells me how to calculate a perimeter. An object, on the other hand, is basically any specific triangle we create. So the class is the blueprint. The object is the actual thing that we're building. We can build multiple triangles, like other is equal to triangle 3, 3, 3. And then I can print out that perimeter. And we'll get a different answer because it's a 3, 3, 3 triangle. So this triangle has 12. This other one has 9. Everybody following so far?
Yeah.
I'm never really sure about how slow to take this one. So. Okay. So we can do other things to calculate a triangle. We could calculate the area. Now, unfortunately, right, how do you calculate if I were to ask you to calculate the area of a triangle, what is the formula for an area of a triangle?
Half the base times the height.
Okay, can you tell me what the base and the height of the triangle are, please? They're not. They don't exist, right? I haven't defined base and height. I've just got 3 sides. Fortunately, again, all you need for it is, unfortunately, all you need for a triangle, and I'm going to go ahead and share my screen. This may be a bit big for you. So I got a new monitor, so I'm very proud of it, but it is ultra widescreen. So this may be a bit of a pain. Okay. So let's go ahead over here. So we've got a triangle and let's see, Control F area. Wikipedia is great. Various methods, see below. So 1/2 base time height using trigonometry. So AB are the A, B, and C are the sides. So we can say, hey, here's the angles, right? Oh, there we go. This one's useful. This is the one we need. Heron's formula. The shape of a triangle is determined by the length of the sides. Therefore, the area can be derived from the length of the side. By Heron's formula, the area of the triangle is equal to the square root of S times S minus A times S minus B times S minus C. No annoying trigonometry required. No sines or cosines or none of that nonsense. Right? So what is S? It is the semi-perimeter or half the perimeter. Okay, so we can use this to calculate the area of a triangle with just the 3 variables we have. Make sense? Everybody following?
See.
Okay, yeah, it's a formula that I have to look up basically every time. I know something like this exists, but hey, do I have it memorized? No, it's right here on Wikipedia. Why would I need to memorize it? I just need to know that it exists. Do we have to import math to do square roots? Yes, we do. So let's go ahead and do that. Import math. All right, so I'm going to go and then I'm going to show you about that nonsense about okay, there's one problem in the file. What's the problem? Oh, right, it's empty. Okay, so get area. So what do we need to do for this one? We need to first, let's calculate the semi-perimeter. I'm going to call it semi-prim for short, is equal to, that's equal to 1/2 the perimeter, right? So 1/2 times self dot get perimeter. So I can't just call get perimeter, right? Because it's like, what in the world are you trying to calculate the perimeter on? In other languages, you could do this, but notice it kind of gives me a warning. It's not defined. So what I have to say is that it's this triangle's perimeter, self dot get perimeter. Remember, self refers to this triangle, anything about this triangle. And anything that has to do with this triangle, I'm the one defining it. So semi-prim is equal to 1/2. And I'm just multiplying by 5 because that's easy, or 0.5 because that's easy. And so now it would be, this is going to be a long statement, but whatever. Return math dot square root, right? The square root of the semi-prim times, and then we have 3 things to multiply against each other. The semi-prim minus A, which was side 1. So self dot side 1. Why don't I need the, so why don't I need self dot semi-prim? Well, the answer is because this is a variable. When we say self dot and do it like this, we are defining something that's going to persist outside of the function that I wrote. So in order for side 1, side 2, and side 3 to exist outside of the constructor, I need to say self dot side 1 and attach it to the self. I have to attach it to me, my triangle. Here, the semi-parameter only matters for the function, so I'm not going to bother attaching it anywhere. So 0.5 is times self.getPerimeter, so self-perimeter to self.side1. And then I'm just going to go ahead and copy paste because that's easy. And remember to switch the variable. The second side and the third side. And remember to switch the variable. Right? So, okay. And run it. Doesn't seem any problems yet. So let's see, a 3, 4, 5 triangle. Right? So we're going to go ahead and get the area of that 3, 4, 5 triangle. Okay. Okay, and we get 6 as the area for the 3, 4, 5, right? Which should make sense to you, which I think that makes sense. How do we draw 3, 4, 5, right? We have, it's, you know, let's go ahead and draw 3, 4, 5, right? For a 3, 4, 5, we have a hypotenuse of 5. And then we have basically a 3 and a 4. Is that correct? So 1/2 base times height. So the area would be 6. So that makes sense there. And then the other one is, whoops, screen share. Meant to just stop drawing on my board. And then the other is 3.8 and a 3.9 minus a bit. Okay. So basically, though, this is a way of organizing our code. So I wrote functions inside of this triangle. But basically, and again, you can only call them by saying this, but only a triangle can use these methods. So these are functions. And I called them a method just now because that's what they are. We use a special word for anything inside of it, for any verb inside of a class, any function inside of a class, and it's called a method. So this is basically how we write objects. So, okay, but what the heck is that? So what in the heck was that turtle.turtle about? Well, let me show you. I'm going to go ahead and save this as a new file. I'm going to call it shapes.py. Okay. Okay, and now I'm going to go ahead and open up so I saved that in shapes.py. I'm going to delete all about objects. Right, and if I want to create a new triangle, t is equal to triangle, I can't just do that. Even though I wrote it, I can't just do that. It's like, what in the world's a triangle? That doesn't exist. I don't see it anywhere. What nonsense are you talking about? So in order to do that, I have to, right? It says triangle's not defined. So, but well, it's defined in my file that I just defined over here, which is called shapes. So if I want to use it, I have to say import shapes. So it does that, and it says triangle not defined. Although interestingly enough, see what just happened? 6, so import shapes essentially runs this entire program. That's cool. It runs it because we printed out when I ran it, it said 6 and then 3, and then it told me triangles not defined, even though we use triangles just perfectly fine over here. Well, what's going on? Triangle is not defined because Python's trying to look inside this file for the triangle. I need to look inside the shapes file for the triangle. So I say shapes dot triangle. And now it should be perfectly fine. And now I just have to give it the 3 arguments. 1, 2, 3. And now it's going to stop yelling at me for this mistake. Okay, another thing that we see here. We see that basically that when I run this, I get the output from the previous program. So this is a bit of an issue because if we're importing this shapes, we don't necessarily want to run our test code like that. So we can do that. We can actually write something to help with that. We can write a main statement, which is weird in Python, but it's just one of those peculiarity of Pythons. Python has some like weirdness that you encounter later on, but the trade-off is that you have less weirdness when you begin, which is more important. So if underscore underscore name, what in the world, is equal to underscore underscore main underscore underscore, then do this stuff. Mentioned that, and now, so now when we run it, there's no issues. I can say just t dot get perimeter, and we get that. Boom, print. We get 6. That's pretty cool. What was the line that prevented from running it again? It was this: if name is equal to main. Right now, what in the world? And so now if I run it here, though, we get that. Now remember, right? If you remember, I had something in here earlier which simply said, "Hey, my triangle is equal to triangle. Print my triangle." And when we get this, it says main.triangle object. And I said earlier that, well, what does underscore underscore main mean? It means it's this file I'm running. Or main means the file I'm currently running. That's what underscore underscore main means. So what does this statement ask? It says if the name of what I'm currently inside, if the name of this file is equal to the file I'm currently running, basically it says if this is the file we're currently executing, if this is the file we run on, then execute this code. Otherwise, ignore it. Make sense? That's all it does. Now let's go ahead and do one more thing. So init was one of those things that was built in, but it looked like there was other stuff built in too, right? Def underscore underscore, right? We have all this other stuff, hash, EQ, new. So there's all sorts of things that basically are really useful. For instance, str is pretty cool. Okay, what in the world is this? Anyone know? Anybody encountered that before in Python?
Isn't it like a suggestion saying like, hey, you should probably use a string for this function?
Yep, it is type hinting. So again, that arrow is just simply the minus and the less than and the greater than sign put together. That's all that is. And then my font's just putting them together. And what it's saying is that basically, hey, if you call, it's called type hinting, and it's letting the interpreter know, hey, if you get this, you should be expecting a string. It's unnecessary. We don't need it, but it's just a cool thing. So what this says, so str is going to solve a problem for us, which is that basically when we print out the triangle, when we say print my triangle, it just simply says main.triangle object at 0x21add68efdo, right? Not very useful stuff, right? It's about as useful as me saying that in a robot voice. So the what in the world? So suppose though, if I want to print out, if I print the object, I wanted to give better information about it, right? Well, that's what the str function is. It says, hey, if I try to, basically it says, hey, if I try to print this, instead I'm going to call this method. That's a Python knows that basically if you try to print this object, look at the str function and know how to print it. And it goes, okay. So let's go ahead and say, so let's go ahead and return a string instead. So first off, I could return just something like this. Look. Look, I replaced the output. Return, look, I replaced the output. But that's not very useful, right? We want to put something more useful in. So what we could do is say something, is that we could say return triangle with sides with sides plus str self dot side one. Let's go ahead and enable word wrapping. So that's all on the same line. So self dot with sides. And now let's go ahead and add some string in between that. So there we go. And now let's go ahead and say side 2 and side 3. So now we've replaced it with a bit more of useful output. So if I print out a triangle now, it says triangle with sides 3, 4, 5. Could also say something like this and make it look like it's a list of some kind, which is perfectly acceptable. Now, the cool thing, now here's the thing about you need to know about objects. Objects aren't a necessary feature, just like recursion isn't a necessary feature, but it can really help programming when you do. For instance, C, which is like the most important programming language ever because operating systems get written in C. It doesn't have objects. It has a weak type of object called structs, which is just simply a way of you can group variables together, but you can't create methods, essentially. That's basically the difference. But it's fine. You can do everything you need. So why are we learning objects? Objects are exceptionally useful for organizing things. Now, again, I mentioned that this is not going to be on the exam. Why? Because, but I'm presenting it now. Why? Because object-oriented programming, if you take a look at the tracks and stuff, it comes up a lot. Plus, it's basically the topic of all next semester. So I might as well let you know what's coming next semester. And also, we've learned now basically why we get turtle.turtle, why that's a thing, because we're calling the turtle constructor for the turtle class, which is located in the file turtle, which has a lot of turtles in it. It's turtles all the way down, I guess. But right. So I am going to go downstairs for a second while we talk about ways to get an example of what we might be doing if I were giving it an exam on this stuff, which I'm not, but it's a good problem and it shows kind of what we want to do here. So give me 1 second. I present to you the world's simplest but most interesting strategy game, Goblet Gobblers. I know, it's silly. Now, I like kids' games because they're typically simple. This one takes 2 minutes to play. It's for ages 5 and up, but my kid has had no trouble beating me at it. And if you look at the board, it looks like a tic-tac-toe board with like some goofy looking characters on it, right? Let's go ahead and stop sharing screen for a second so you can get a better view of this, right? So view, right? So, right, Goblet Gobblers. Looks like a tic-tac-toe. Gobble up, line up and win. And it is tic-tac-toe essentially on a board. So this is what we're gonna work on for the rest of today and tomorrow. So, so it's very simple. You've got pieces, which we really don't need to represent, but they create our board, which I will put down here. Now I briefly considered using this game for the final exam, but honestly, it was more trouble than it was worth, but it's a good example of object-oriented programming, I think. So let's go ahead and see. So there we go. We've got our thing. And basically we've got these pieces. We've got blue pieces and red pieces rather than your X's and O's, okay? And you'll notice that they're of different sizes. And if you could pick them up, you would notice that they're hollow. You've got we've got, so there's 12 pieces total, 6 blue and 6 orange. So let's go ahead and move the blue to the side, shall we? And let's focus on our orange pieces. We've got 2 big gobblers. I know, so silly. 2 small gobblers. Sorry, 2 medium gobblers and 2 small ones. So there's 2 players. Everybody has, and both players have 2 small, 2 medium, and 2 big. Okay, makes sense? Okay, so how does this game work? Well, it works like tic-tac-toe, but with different moves. The object is to get 3 of your pieces in a row. So for instance, I take my turn, I pick up one of my pieces, I put it here. And then and then the other player can put a piece here. And here's the rub. I can take any piece. So here I have 2 options now. The first is that I can take a piece and place it anywhere on the board. If my piece is bigger than a piece that already exists, I can just place it on top, including on my piece, which is useful for feints and deceptions and stuff. Or I can pick up a piece that already exists on the board. So for instance, I could gobble that piece up. He could gobble this piece up. I could put my piece here. And if he tries to put his piece here, I can gobble it up and get 3 in a row like that. So that forces him to put this piece, which also attacks that way, which I'm safe to put a piece this way. And again, and so what he has to do is that basically at this point, he can't put a piece here because I could put that there. So he has to, so one of the other things you can do, again, is rather than just choosing a piece, is you can pick a piece up and move it like that. And if you happen to move a piece that has a piece under it, well, that piece is now there. So it's pretty cool. So now, if I were to tell you basically and say your homework assignment is to implement this game on a computer, things start getting a bit frightening, right? Think about it for a second. How do we organize it? It's just tic-tac-toe with pieces that can overlap each other, right? I mean, how hard could it be? But this is where object-oriented programming comes to the rescue. Okay, and maybe I won't spend the time writing this program, but the point being is that object-oriented programming makes it so that we can kind of create a nice big outline for everything we need to do. Okay, so let's see, that is all the pieces, definitely. By the way, if you've got like very young siblings at home or something, or like very young nieces and nephews that like board games, this game was like $15 on Amazon, and it's fantastic. And like your kid, and like the kid will beat you occasionally. It's fun like that. Like my son has beaten my wife, and she was actually trying. Same with me, because it's a very small space, so it's easy to make mistakes. All right, but how would I organize this? Well, let's go ahead and share. Well, the first thing I'm going to do is that I'm going to create objects. So let's go ahead and share my screen. Share screen. So I'm going to go ahead and create objects. So first, create a file called Gobbler, right? But everybody understand how the game's played. You have pieces, you have a board, and you have players. So let's go ahead and talk about that. Okay, so you've got 2 players. That's a noun, right? Class player. Okay, and maybe it's useful if I keep track of wins and losses. So what do we need to know? What's going to define the player? That's what our constructor is. Def init. I think all we need to take in is one thing, because that would be the color of what that player's color is, right? Are they red? Sorry, are they blue or orange, right? Self dot color is equal to whatever color there's defined, and then we're going to say self dot and then we can keep track here like of how many pieces we have. We can organize that differently, but we can say this player has how many of each? Bigs is equal to 2, right? We're initializing this, right? Each player starts with 2 bigs, 2 mids, and self dot smalls, right? And this basically gives us a way of outlining everything about the player. And now I've just defined basically this is what the player has, right? Although that might not be the way of doing it, because another good way of doing that might be, and another thing about object, you know what? I'm going to comment this out for right now because I don't know if that's how I want to do it, but I've got an outline. Here's the players. So I'm going to arrange the objects and then I'm going to see how I can interact with them. Why don't the sizes need to go into init? Because that's an excellent question. Because the decolor is going to depend on when we create the object. But when we create the object, regardless of whatever we pass in, we know they're going to have 2 bigs, 2 mediums, and 2 smalls, right? No matter what. For the triangle, right, when we were defining the shape, we did not know what the shapes. Sorry, when we were defining the shape, we did not know how long each side would be. So we had to define those and pass those in. Here, we don't, they're going to be the same regardless. But let's go ahead and define a piece. So we're going to define a piece as having 2 things, right? So when we create a piece, we create it with 2 variables, right? Because each piece is going to be different. What defines a piece? It is the color and it is the size, right? So there we go. Color and size. And we're going to just simply say self.color is equal to color. Self.size is equal to size. And let's go ahead and say size is int. Yeah, that's going to be easy. Size is int either 1, 2, or 3. Blue or orange. Yeah, I can see now. So writing these things out and just kind of outlining it, you can kind of see, like, I am actually doing a significant amount of programming here, but it looks more like an outline and it feels like writing an outline, which makes it really easy to implement. So we define it, and heck, I can like write a piece of actual code right now that I'm going to find very useful. Which I'm going to say can gobble, right? Self and other, right? Can I gobble this other piece, right? And that's pretty simple. If self dot size is greater than other dot size, return true. So if I'm bigger than that piece, then I can place my piece on top of it. And there I've written a piece of code that we can obviously see be used a whole lot in this program. Def. Oh, and right, we need to also finish up that else. If we're not bigger, if we're the same or if we're the same or less than, return false. Makes sense, right? So now what I can do here is I can say, so for the player, we can define them as having a collection of pieces. So all objects have 2 relationships with each other. One is has a relationship. For instance, a piece has a color, a piece has a side, has a size. A player has a color, and they also have a number of pieces. So don't know. So we don't know necessarily how we're gonna represent the player having the pieces yet, but that's the relationship. And then there's the is a relationship, which is called inheritance, and you learn about that in 1068 more detail, where basically we can reuse some pieces of objects where you have, like, for instance, a snake is a type of reptile. A snake, a lizard is a type of reptile. So if I have a nice handy reptile class, I can use that as the basis for writing a snake and a lizard class. Very useful stuff. And then we can outline the board as well. So let's go ahead and think about how we do the board. The board is a grid. So class board def init. I mean, why not just call it grid? And then we can just make a 3x3 empty grid. So def init. So how do we want to represent a board? Right? Like, do we want to represent it as like, I think the easiest way is to have it as a list of lists. So basically we would say, hey, we have so I could say basically like this, self dot grid is equal to, so we have 3 rows, and so we have 3 rows, and those in them have, each row has 3 spaces, which I'm going to say are each none. There's nothing in them, which could lead to problems later because you don't want to interact with nuns. You replace them if they're there. But that's a useful way of basically saying that they're there. So def dot, or you could create like size 0 colorless pieces if you wanted to. But that seems a bit weird and technical. So that's our board. And then basically we have to check if there's a winner. So I would just simply leave it blank for it, but we'd leave that blank for right now. And so basically then, let's see what else I would do. I would say player has self. So self dot pieces. Self dot pieces. This might look a little weird. So I'm going to have a list of all the pieces that we have. Okay. And I'll say self dot self dot append. And this might, yeah, I'll break it up into 2 lines. So now let me go ahead and, so I've got a list that's going to hold all the pieces. So I'm going to now make all the pieces in manually like this. Piece going to be the same color. And we need a 2. And so, and then what we'll say P is equal to piece. And then we're going to do self dot pieces dot append P, which would add it there. Of course, I'm skipping a step. What I can do is just simply say, hey, make a new piece, put it in my list. Let's go ahead and then we can copy that quite a bit. Okay, and so now 2, 1, 1, and 0, 0, right? And then I've created all the pieces I need. Let's go ahead and now test this. To test this, I need to actually have something to write. So like def str. So let's go ahead and write this. So return color. I'm going to return piece. Actually, I'm just going to return color plus str color, which should be a string anyway, but I'm just going to be cautious there. Plus space str size. So when we create a piece, if I print it out, I'm going to, oh, right. And I have to say this guy, right? I got to remember myself. Again, I'm coming from Java where the syntax is slightly different. So what I'm going to do is I'm going to basically, for piece, I'll print out the color and the size. And for the player, I will write its own method. Return str color player has, and this is going to be really cool, which is I'm just going to print out self dot pieces, which is a list. So let's go ahead and see if this works. Right, self dot color. So let's go ahead and create a player. P1 is equal to player. And I'm going to say, I'm going to create him as the orange player. And then I'm going to print out and see what happens and see what explodes. Okay. Okay. So player has self.pieces. Okay. Saying, hey, you got to you need to actually, it's a list. So you need to convert that to a string if you want to print it out. No problemo. And it says orange player has main piece object, main piece object, main piece object, main piece. Yeah. Okay. So how do I get it to print out all the things without it necessarily doing that? So has, what if I did? So let me first off see what happens if I try calling it on piece 0. So orange player has orange 2. So, okay. Now so I can do this. It's just going to take a bit more of either something about the way list works that I need to understand, but I'm just going to go ahead and just do this. Output is equal to string self.color plus player has. And now what I'm going to do is I'm going to create a for loop and iterate through all my pieces. So for piece in self.pieces. So for every piece I have, what am I going to do? I'm going to say the output is equal to output plus piece turned into a string. The string representation of this piece, please. And that's what the string function does, is that it calls this object and says, hey, what is it? And then, so that should call the string function on the inside, I believe. Otherwise, I'm in a world of hurt. There we go. Orange player has 2 no, that's not the way I wanted it to say. So let's see. Player has output.string plus space over there. And then the rest is just formatting here. Let's see. So orange player has. So orange player has orange 2, orange 2, orange 1, orange 1, orange 0. And then I have a fence posting problem, which just simply means that I need to return output without the last up to, but not including the last 2 strings. And I'm just going to replace last 2 characters. And there we go. So there. And so with this single function, basically this player orange, and by just defining stuff like this, we see that basically I've created a player and defined everything he has right here. I have a piece, and now I've got a function that tells me, can I put one piece on top of another? Which is a really cool, which seems like it'll be really useful in the future. Right? So, all right. So on Thursday, would people want me to continue working through this or move on to something else?
By saying continue like working through this, do you mean like continue teaching like our object-oriented programming?
Yes.
Yeah, I'd rather that.
Okay, cool. I'll be happy to. So next, so on this upcoming Thursday, we will continue with this game, and basically we're going to try to turn it into a fully fledged 2-player game. Okay. Why not an AI one? Because believe it or not, while tic-tac-toe is fairly easy to implement for an AI, fairly easy because it has, as like compared to chess, easy is relative. It's not exactly like super easy. And this basically has, if you could tell when I was running through it, a lot more depth. So, okay, this is very exciting. And again, I heartily recommend this game if you've got a child in your life who basically likes board games, or if you need, or if you want somebody to teach deception and cunning to, because those are always really useful traits to have. Well, that sounds bad when I say it. So anyway, also I'm aware that I think there will be our students who are observing Ramadan. So if you need, so first off, I hope you have a meaningful fast if you are observing Ramadan. Second, if you need any accommodations, because I know fasting can sometimes be like make you not feel awesome, just let me know. Okay, so that's all. All right, I'm going to be happy to going to go ahead and start